Electric field due to a circular arc. Here a circular arc is shown with positive charge, and the total charge on this arc is given q, and linear charge density is lambda. If we, this is y axis and this is the x axis. If we take a element of length dl at angle theta, then decrease the charge on this element, and d theta is the angle subtended by this element at origin. So due to this element, electric field at this point will be in this direction. Similarly, if we take another element at the same angle in other side, then electric field due to this element will be in this direction. Now if this is theta, then it also be theta, and if it is theta, then it also be theta. So d will have two components, d sin theta and d cos theta. Again, for this d sin theta and d cos theta, d sin theta will cancel out, and both d sin theta will add to become d cos theta will become add to become 2d cos theta. Now dq will be lambda dl, or dA equal to 1 by 4 pi epsilon naught dq by r square, 1 by 4 pi epsilon naught lambda dl by r square, 1 by 4 pi epsilon naught lambda, because dl equal to r d theta by r square, or 1 by 4 pi epsilon lambda d theta by r. Consider a circular charged circular arc of radius as shown in the figure. This circular arc is placed symmetrically about y-axis. Consider element dl of dl an arc in both sides. The net electric field due to element on both sides is d net equal to 2d cos theta, and d net equal to 2 into 1 by 4 pi epsilon naught dq by r square cos theta, 2 into 1 by 4 pi epsilon naught lambda dl by r square into cos theta, or 2 into 1 by 4 pi epsilon naught lambda r d theta with dl equal to r d theta divided by r square into cos theta, 1 by 4 pi epsilon 2 lambda by r into cos theta d theta. So net force will be E net equals to integration theta to theta naught by 2 d net equal to 1 by 4 pi epsilon naught 2 lambda by r theta to theta naught by 2 cos theta d theta, or 1 by 4 pi epsilon naught 2 lambda by r integration of cos theta equal to sin theta. So, and the limit is theta to theta naught by 2, 0 to theta naught by 2, and all places it is 0 to theta naught by 2, 0 to theta naught by 2. So E naught will be 1 by 4 pi epsilon naught 2 lambda by r sin theta naught by 2, where theta naught is the total angle subtended at the arc at the origin, and this value, that is lambda by 2 pi E net equal to lambda by 2 pi epsilon naught r into sin theta naught by 2 along axis in outward direction, that is away from the arc along the y axis. Case 1. Case 1, if the arc is semicircle, then theta naught equals to pi, and hence theta naught by 2 equal to pi by 2. So E net equals to lambda by 2 pi epsilon naught r sin pi by 2, and sin pi by 2 equal to 1. So E net equals to lambda by 2 pi epsilon naught r. This is shown here. Electric field will be in this direction at this point. Lambda linear charge density. Case 2. If the arc is a circle, then theta naught equal to 2 pi, and theta naught by 2 equals to pi, hence E net lambda by 2 pi epsilon naught sin pi equals to 0, which is expected. Question: P is the midpoint of arc AB. What is the electric field at O along x-axis? This is a arc AB of given 60 degree. That is theta naught is given 60 degree. So if we pass a line, and this line is shown here, it is x-axis, and this angle is given 15 degree, and this is the middle point, and a line is passing through this middle point connecting O to in this direction. So this will be theta naught by 2. So here theta naught by 2 is 60 by 2 is equal to 30. So first we have to calculate the net electric field in this direction, and then we have to take, because if this is 15 degrees, then it also will be 15 degree by the alternate angles. So we have EPO, that is electric field along PO. EPO equals to lambda by 2 epsilon naught R sin 60 by 2 along PO. So electric field along x-axis will be EPO x equal to EPO cos 15 degree, or lambda by 2 pi epsilon naught R, and sin 30 degree equal to 1 by 2 into cos 15 degree. This will be the answer. Find the electric field at P. This is the situation. And third one is here. Let first show the first one. The situation is here shown. Electric field due to this arc will be in this direction, passing through this point, at the middle point, and this is an infinite length of rod of infinite length. These are also rod of infinite length, and we have to find electric field at one end, and we have developed formula for this. So we now, because this distance and this distance is same, so electric field due to this line of charge will be equal to the electric field due to this line of charge, but direction will be opposite to each other. So these two will cancel each other, that is E1 and E2 cancel each other. So we have either written here E net equal to E1 vector plus E2 vector, E3 vector. In vector form, E1 I cap plus E2 into minus I cap plus E3 j cap, because it is in this direction. So E1 minus E2 I cap plus E3 j cap, because since E1 equal to E2, so this will cancel out, only we are left with this value. So E3 equal to E3 j cap, and now hence E net will be the value of E3 lambda by 2 pi epsilon naught R, and this angle will be sin pi by, because theta naught is here pi, so theta naught by 2 will be sin pi by 2, or lambda by sin pi by 2 equal to 1, so lambda by 2 pi epsilon naught R answer. In case 2, these are positive line charge, but these are negative, so electric field at this point will be in this direction. Again this one E1 and E2 will cancel out, and there we are left only we are left with E3. So E1 and E2 will cancel out, E3 will be in this direction, minus E3 minus j cap. So lambda, if the linear charge density is lambda 2, then it will be lambda 2 by 2 pi epsilon naught R. In the third case, the situation is shown in figure. Again, this is positive and this is positive, and this is positive also, or maybe negative. If it is negative, then direction will be E2 will be in this direction. If it is positive, direction will be in this direction. So electric field due to E1 will be in this direction, and E2 will be in this direction. So here it will not cancel out each other. So we have to take resultant of E2 and E1 and E3, and then add to E2. If this is positive, then this will add. If this is negative, then it will cancel out E2. So first let us consider this is negative. Then this electric field will be in this direction, E2. So E net will be E1 plus E2 plus E3. Now E1 is lambda 1 by 2 pi epsilon naught r into I cap plus, and E2 will be E2 cos 45 into I cap plus E2 sin 45 j cap, and E3 will be E3 into j cap. So lambda 1 by 2 pi epsilon naught r into I cap plus lambda 2 by 2 pi epsilon naught r cos 45 equal to 1 by root 2 I cap plus lambda 2 by 2 pi epsilon naught r. So here, because it is negative, so this will be E will be in this direction, and so E2 will be in this direction, E2. So E2, if we take, if this is 45, then it is also 45, this is also 45, then E2 cos 45 into minus I cap, and it will be minus j cap plus E3 j cap. So we have lambda 1 by 2 pi epsilon naught I cap lambda 2 by 2 pi epsilon naught cos pi by 4 into minus I cap, and lambda 2 by 2 pi epsilon naught sin 45 degree into minus j cap into j cap. So this will be equal to lambda 1 minus lambda 1 by 2 epsilon naught r minus lambda 2 by 2 root 2 pi epsilon naught r, because sin 45 equal to 1 by 2 root 2 into I cap, and plus lambda 3 by 2 pi epsilon naught r, and this will be minus lambda 2 by 2 root 2 pi epsilon naught r. Answer. Next, find the electric field at P. This is point P. Now we can, and A and B. Now in A, electric field due to this part will be in this direction at angle 45 degree from this axis, and electric field due to this part will be in this direction at 45 degree. So we can find directly magnitude, or you can also write in vector form. E net equal to under root E plus a square plus E minus a square, or E plus E lambda by 2 pi epsilon naught r sine, because this whole angle is pi by 2, then it will be sine pi by 4. Value is lambda by 2 pi epsilon naught r sin theta naught by 2. So sin theta naught by 2 will be sin 45 degree, that is pi by 4. This will be pi by 4, because this angle is 90 degree, so half will be 45. So sin pi by by 4. So lambda by 2 pi epsilon naught r 1 by root 2, 1 by root 2, so lambda by 2 root 2 pi epsilon naught. Similarly, E1 में lambda by 2 pi epsilon naught sin pi by 4 equal to lambda by 2 root 2 pi epsilon naught r. So magnitude will be under root this lambda by 2 root 2 pi epsilon naught r to the whole square plus lambda by 2 root 2 into pi epsilon naught r to the whole square equals to lambda by 2 root 2 into pi epsilon naught r into under root 1 plus 1 or lambda by 2 pi epsilon naught r along PA vector. Because if this is 45, this is 45, so its direction will be in this direction. Because both have same magnitude, so resultant will pass through the middle point of the resultant will pass through the middle point. As the situation is shown, we have calculated E naught under root E plus a square plus E minus a square. E plus is this value because this is in this direction, and here whole theta naught is pi by 2, so theta naught by 2 will be pi by 4, so we have put in pi by 4. Now root 2 root 2 pi epsilon naught. Similarly, E minus equal to lambda by 2 pi epsilon naught sin pi by 4 equal to this, and E need to will be like this, and solving we will get along, and the direction will be along this. Next, here situation is shown. This is positive charge and this is 60 degree given, so its resultant will be at 30 degree from this line, so this will be 30 degree again. For this will be 30 degree, and this whole will be 60 degree. Angle between these two force is 60 degree. So E net will be E plus cos 30 plus E minus cos 30 equal to E plus cos 30. Since given mode of E plus mode of E minus equals to lambda by 2 pi epsilon naught r equal to sin 30 lambda by 2 pi epsilon naught 1 by 2 or equals to lambda by 4 pi epsilon naught r. So sin this will cancel each other, and only we are left with the component of with cos theta. So 2e plus cos 30 degree or 2 into lambda by 4 pi epsilon naught r into root 3 by 2, and solving finally we get root 3 by 4 pi into lambda by epsilon naught r, or E net equal to root 3 into lambda by 4 pi epsilon naught r along PA vector. Next, find the total force on infinite charged rod. This is infinite charged rod, and we have to find the total force. This is a charged ring, and if charge is given Q, and here only linear charge density is given. So to find the force on E, first we have to take the elementary charge at this point, and then we have to calculate the we know that the electric field at a distance x on the axis of circle, and so we multiplying this charge with electric field will give the force. So elementary charge on rod dq equal to lambda ds, electric field at P due to ring is, we know that E equal to 1 by 4 pi epsilon naught qx under root x square plus r square to the power 3 by 2. Hence elementary force due to ring on elementary charge df equal to dq into E, or lambda dx into 1 by 4 pi epsilon qx by under root x square plus r square to the power 3 by 2. Hence f net equal to 0 to infinity df lambda q by 4 pi epsilon naught integration 0 to infinity x dx by x square plus r square to the power 3 by 2. 0 to infinity of lambda q by 4 epsilon 0 to infinity x dx by x square plus r square to the power 3 by 2, and this will be equal to lambda q by 4 pi epsilon naught r, because 0 to infinity x dx by x square plus r square to the power 3 by 2 equals to 1 by r. So here we have calculated the value.